Good day, everybody, and once again we're back together. We are looking at Euclidean Geometry, a technical maths paper 2. So please, if you haven't subscribed, just make sure you are part of the family. All right, let's quickly have a look at question 7. So they say AB is a chord of the circle, right, with the center O. So we know if we've got a center, we've got our radii, we know that OB should be equal to OA, should be equal to OE, that entire side over there, right? That's still a radius. Now, what else do we note in that case? They say to us AD is 12 units, ED is 8 centimeters, as well as OD is equal to X. All right, now let's get into it. They say determine the radius OB in terms of X. So if I look at it, just like I said to you, that's the radius. And you remember that ED is 8 and OD is X. So I know that EO or OE would be equal to OD plus DE. And so that will be OD is X and D is 8. So in this case, which means OE is 8 plus X, but we know that OE is equal to OB. Why? Because they are radii. And so that means also OB must therefore be equal to 8 plus X. All right, now they say to us, hence calculate the length of the radius OB. So we want to know how long the radius OB is, right? And not in terms of X, but this time around looking at it in terms of the dimensions that we're given. Now I want us to note in this case, we've got this side here we know is 12 units, okay? And so I'm going to say in triangle, so for 7.1.2, let's do it this side, 7.1.2. So in triangle ODB, so that's ODB, I know that OB squared would be equal to OD squared plus DB squared. But I also know that DB is equal to DA or AD, and that's equal to 12 units, and that's given. Okay? Oh, I actually almost forgot a very important detail before I even get to that. Why would I use theorem of Pythagoras here? Because in this case, I'm using theorem 1, a line drawn from the center that bisects a chord is perpendicular to that chord. Sorry, I didn't mention that. So in this case, what does this say to us? That firstly, angle ODB is equal to ODA, angle ODA, and that's equal to 90 degrees. And why would that be the case? This is line from center bisects a chord. Okay, right. Now I want us to note, ladies and gents, so we know that's 90 degrees. So then what does it say? It says, therefore, we can use the theorem of Pythagoras, as we said, OB squared is equal to OD squared plus, so OD squared plus DB squared. Okay, so we know what OB is, right? So we know that OB is that entire 8 plus X thing, which is equal to, okay, OD that's x squared, plus db, which is 12 squared. Right, now ladies and gents, all that we need to do now is just work with what we have over there. So I'm going to say, well, this is going to be x squared. So this is 64, right, plus 8x times 2, that's 16x, plus x squared. So I'm expanding that bracket over there. So for those of you that have seen me do this, so remember, whenever you've got a square bracket, that's going to be the first term squared, the last term squared, there it is, and the middle term, you always multiply both your terms and you multiply by 2. Okay, so 8x times 2, that will give us 16x. Right, and this is equal to x squared plus, right, 12 squared is 144. And now, ladies and gents, can see this guy and this guy cancel each other out. Okay, I'm going to take all of my x terms. So I've got 16x on the left-hand side. And I'm going to take the 64 to the other side. So this would be equal to 144 minus 64. Okay, so 144 minus 64, that gives us 80. So 16x is equal to 80, and if we divide it by 16, in this case, so 80 divided by 16 is equal to 5 units. Okay, so now we were looking for the length OB. So OB will be equal to 8 plus x, so that's 8 plus 5. This will be equal to 13 units. And that is really how the cookie crumbles, ladies and gents. I hope that you were able to follow, and we will be looking at the next question in the next video. For now, I'll see you guys next time. Sharp, sharp.